By the way, how are projects coming along? Projects are due a week from Friday. To be on track to be done in time, you need to have your data in SPSS by Friday of this week. So you don't have to turn anything in to me. But what I'm looking for is that for you to be on time, you want your data collected and in SPSS by Friday this week. If you don't have data in SPSS by Friday this week, worry. If you do have the data in SPSS by Friday this week, you're in pretty good shape. Okay? So you're going to get the data into SPSS by Friday.
How do you define Friday? Is that like Friday before class, or can we do it Friday after class?
Anytime. You're not turning anything into me. This is your own milestone. So if you want to have it set so that it's before class, that's up to you.
Well, I probably won't go to class until after.
Once you get your data into SPSS, you're going to want to save it to a file, distribute it to the group members. Each of you then can do your own summaries and your own graphics. And then you're going to merge that back together into a report to be turned in a week from Friday.
So we can do all of that, we can do like the report and graphics and stuff separately, and then just like...
Pretty much, yeah.
Right before class, you would like combine them all together then in one.
Well, I wouldn't do it just right before class, but...
yeah, we don't have to work on that together, that part.
Not necessarily. It's pretty much individual. And if you look at the example that I gave you, each individual section had its own set of graphics and description and so forth.
Okay, so pretty much all made is the SPSS data file.
Yep. And that's why I'm saying if you can get that done by this Friday, get that distributed to everybody for this weekend, you've got time to work on it, you can get things done and then kind of pull it out to everybody. Okay, noise level indicates to me that we ought to be talking about some stuff up here. Let's walk through this problem. Number 21, part A. Confidence interval in this case is x bar plus or minus t star times s over root n. So they've given us x bar, s, n, and then we tell us a 95% interval. So we can start by writing 76 plus or minus. We know that we're going to have 6 over the square root of 9. In here, what do we have for the t star value? 2.31. We look up in row 8, so the sample size is 9. Look up row 8 in our A.2. For 95%, it says the multiplier is 2.31. So that's our multiplier. Okay? Now, when you turn this kind of stuff in, make sure that you write this down somewhere. Okay? So I know what you put in, so that if your numbers are off, I have something that I can look at and give you credit for getting things set up correctly. So I basically know where the mismatch came. This works out to 71.38 to 80.62. So the interval is actually from 71.38 to 80.62. But this is the main thing I'm interested in. Okay? Part B. For part B, the only thing that changed was this 90%, right? So we're going to have 76 plus or minus the same standard error. What was the t star multiplier here? Yep. Jumping down to C. Now we're at the same confidence level, but we're changing the sample size. So the 76 is the same. The multiplier is going to be the same. The standard error will have the same numerator, and the denominator changes to the square root of 16.
Wait, how is the multiplier the same? Shouldn't it be,
That's got to change, doesn't it?
well, should it be 1.75?
Just making sure you're awake, all right? Okay, so the multiplier changes when we change the sample size, didn't we? Okay. Part D. We've got the same mean. We've got a 95% interval now with a sample size of 16. So it's going to be bigger or smaller than that?
Big.
It's going to be bigger. What size is it?
2.13.
And then this stays the same, standard error, 6 over the square root of 16.
8.
8 over the square root of 16.
Oh, you weren't even testing us that time.
Ooh, ooh. You guys got to keep me straight. Because they did change S on us, didn't they? From there to there. Okay. Now let's be more careful on this one, okay? S is the same, N is the same, confidence level is the same, X bar changes. Okay? So that means you have 100 plus or minus 2.13 and 8 over square root of 16. Okay? Not too bad, is it? Calculating confidence intervals are fairly straightforward for these cases, particularly for single means like this. The toughest thing is going and looking up the values in the 8.2 table. Okay? What about 22? What 3 factors affect the width of a confidence interval for a population mean? For each factor, indicate how an increase in the numerical value of the factor affects the interval width. Let's go back over here. What part of this is the width of the confidence interval? The multiplier has to do with the width. Is that all? All 3 of these. So it's actually this whole thing here. That margin of error. Essentially how far above and below the estimate you're going to put those fence posts. Okay? So what are the 3 factors that can affect that width? What's the first one? Pick one. Multiplier. Okay. What is it about the multiplier that affects the width?
It's wider if it's bigger.
Confidence level is what's coming in the multiplier. Okay? If I increase the confidence level, what does that do to my width? Sure. If I want to be more confident that I've captured that true population parameter, that means the interval has to increase in width. So that means the width also increases. What's the next factor here we want to look at? 2 other things to look at, right? We look at standard deviation here. If S so if this standard deviation increases, what happens to the width of my interval? Sure. And we saw that in the data that we had here at the beginning of class, didn't we? We looked at a series of intervals calculated from data, and we could see that when the spread of the data increased, that would increase the estimate S here. And when that spread increased, the interval got wider, didn't it? So, increasing the variation, or the spread of the data in the sample, will increase the width of the interval.
What does that stand for again?
Sample standard deviation.
Okay.
It's just a standard deviation calculation for the data in the sample. How about N? It's our 3rd factor. If N increases, what does the width do? Sure. The denominator of this term right here, if you increase the denominator, the overall value decreases. So as we increase N, the width will decrease. Okay? Those make good quiz questions. Okay, let's take the next 5 minutes or so and work through 1124. And then we'll talk about the answers to that one.